This video will show an example on how to find a projection of a force using the dot product method. In this example, we have a pole which is being pulled from the ground using a 300 Newton force in the horizontal direction. This question is asking us to calculate how much force is actually pulling in the direction of the pole, which basically means finding this projection force which is in parallel or collinear direction with the pole. To solve this problem, we need to use the formula projected force is equal to force vector dotted with the unit vector, and this is multiplied again with the unit vector. Our force vector in this example is 300J. And our unit vector can be derived from this position vector that is given. To find the unit vector, we take the position vector and divide it by the position vector's magnitude. Once this is calculated, you should end up with a unit vector which is below. The next step is to solve for this f.u. To do this, we use the formula fx ux plus fy uy plus fz uz. And this is basically taking the x, y and z components of each vector, multiplying and then adding them together. So for the first part, fx would be 0 due to this force here not having any x component. And the u would be minus 0.22. Plus fy should be 300J. So 300 multiplied by the 0.44 plus fz, which again, this one has no z component, therefore it's another 0.87. This is calculated correctly, you'll get an answer of 132 newtons. This is a scalar value that doesn't have units of I, J and K. What we have found is a magnitude of this force projected here, which is in the same direction of the pole which is being pulled out. Lastly, we need to convert this into a vector, and to do this we multiply by the unit vector which we found earlier. Therefore, the projected force is equal to 132 newtons multiplied by the unit vector. If this is done correctly, you'll end up with... Lastly, we're going to find the perpendicular vector to the projected vector which we found earlier. To do this, we take advantage of the formula. The force vector, which is 300J newtons here, is equal to the perpendicular vector plus the projected vector. Rearranging this, we can have the perpendicular vector equals the vector that is known minus the projected vector which we found. Putting all the numbers in, we would get the perpendicular vector is equal to 300J, which is this vector here, minus 29.04 I plus 58.08 J plus 114.84 K. Simplifying this, we would have 300J Minus and minus become positive, plus 29.04i, minus and a plus is a negative, 58.08j, minus and a plus is negative, minus 114.84k. Subtracting these two j's, you end up with a final answer of